Okay, let's look at another way we can actually add refrigerant to an air conditioning system. So as your module talks about, another way we can add the correct amount of refrigerant by weight is by using a scale. So let's just have a quick look at the bottle. Let's have a little bit of review. So on this particular bottle, we actually have two valves. The blue valve will signify vapor. The red valve will signify a liquid. When I open up the blue valve, it's actually going to pick refrigerant right up from the top of the bottle. The red valve actually has a spigot or a valve or a tube that actually goes down to the bottom of the bottle and it will pull up liquid. So you'll notice I've hooked up the center utility hose to the bottle, and the bottle has been now placed on a scale. So what we're going to do is we're going to add refrigerant in a vapor state into this machine. So I'm going to open up the blue valve. And I'm going to turn on the scale. And now I'm actually going to tare it. So you can see now it's showing a 0, 0, 0, 0. So now I'll be able to add refrigerant by weight. So what I actually want to do is add about 8 ounces of refrigerant in a vapor state. So first thing I'm going to have to do is turn on the air conditioning system. And what I'm going to do is with the system running, I'm actually going to add refrigerant into the system. So with the system running, we'll wait till the compressor kicks in. And what you'll notice is when the compressor is running, we'll be able to watch our gauges. So with the compressor running, you can see the blue gauge drops down and the red gauge rises up. Okay. Okay. So what we're going to do is wait for the compressor to kick back in, and we'll be able to tell the compressor kicks back in because we'll see the gauge drop down. So when the gauge drops down, we're going to open the blue valve, and we're going to stay about 45 to 50 PSI. And in doing so, you can see I've actually put in half an ounce, 1 ounce, and the compressor shut off, so I got to turn the valve off. Compressor kicks back in, staying about that 45 to 50 PSI. Okay, I've done 1.5 ounces, 2, 2.5. Compressor shuts off. Turn the valve back on. 3, 3.5, and compressor shuts off. Four, 4.5. Now you should start to notice the compressor is actually starting to run a little bit longer. Now, one troubleshooting tool you guys will have, which aid you in your career as an AC technician, is when I have an orifice tube system, which is this one here, when I'm undercharged, the compressor will cycle on, off, on, off, on, off, on, off. But you'll notice as I add refrigerant, the compressor starts to actually run a little bit longer. So like I say, I'm going to try to get 8 ounces into this, and then we'll let it run and digest it. And at that course, that time, after it's ran for 5, 10 minutes and digested the refrigerant I've added, we can do our measuring, look at subcooling and superheat and our vent temperatures. And then of course, using those numbers now, we'll be able to determine how close I am to a full charge. So I need to add 1 more ounce of refrigerant into this system. Open the valve up again. We stand about that 40, 45. And we'll let the compressor pull in the last little bit of refrigerant. Here, I've got my 8 ounces refrigerant. So as I said before, now I'm going to actually let the system digest. And this is where we can't rush air conditioning. It takes 5-10 minutes to digest the refrigerant I put in there. Then we can actually measure our subcooling and superheat and determine how close I am to a full charge. Just a little bit of review on reading the gauges. You'll notice when the compressor shuts off, the blue gauge rises and the red gauge drops. The reason the blue gauge rises is now that we have no refrigerant pumping through the system, it is drawing heat from the classroom. And as it draws heat from the classroom, the refrigerant boils, so we get heat, so the pressure rises. Because I'm not pumping refrigerant, the low side drops because I'm not building any pressure. Okay? So that's filling the system using a vapor and a scale.